Hey, the sleepy lunch group is here, or sleepy post-lunch group, so hope to keep you guys a little engaged despite the full stomachs. But anyway, my name is Nikki Attea. I'm going to be standing up here for the next 30 to 40 minutes, so I figured I would let you in on a few personal facts about myself. I play beach volleyball. I love fine wine and cheap beer. It's a tongue twister. And I'm a mom of 2 mutts. But this is also the slide where I'm supposed to tell you why I'm the right person to be giving this talk. I have a long history with testing and monitoring and broken things, some of those more than the others. Previously, I was at Apple, where I maintained automation frameworks for performance testing. And currently, I'm a software engineer at Sensu. Hopefully you know that we monitor stuff. If you don't worry. And stuff has been breaking on me basically my whole career. I'm sure you all have similar experiences, so let's talk about them. Can I get a show of hands? Does anyone know what Sensu is? Have you used it before? Users? Couple? Okay. So we have a little bit of a learning curve, but we'll go through it. So as a monitoring event pipeline, it collects, processes, and routes different event types, including discovery, availability, telemetry, and alerts. By executing service checks on monitored nodes, it creates events that it can filter, transform, and handle. So the slide you see up here, that the event pipeline is everything that you see on the back-end side with those 3 resources. It follows the monitoring as code ideology. So the pipeline is extremely powerful and completely customizable. So anything you can write code for, you can put into Sensu. But for right now, just think Nagios on steroids. Now, that product background is not meant to be salesy. In both our internal processes at Sensu Inc. and the common use cases of our external product, Sensu, we tightly integrate with InfluxDB. In this talk, I'm going to take you through some of those use cases so you can hopefully draw some inspiration from our processes and suggested workflows. The first internal process involves the DevOps strategy behind testing and releasing our product, including some story time for how and why we evolved to that point. So let's talk release QA. So building software is easy. Don't quote me on that, but designing, architecting, specifying, and validating software are all a part of the development lifecycle. And if all of those processes are executed perfectly, actually building the thing can be pretty easy. Oftentimes when there's a buggy feature, it's not because the code is bad. I mean, it's sometimes because the code is bad, but it's usually indicative of a rushed design or a poor spec. Kim Goodwin had a similar take on Twitter, where she said, "I am convinced that a lot of technical debt is really problem definition debt. It exists because nobody took the time to define how the tool or the data would need to be used over time, even though many of those uses are easy to anticipate." Personally, I couldn't agree more, but I would also add that in these instances, it's often because nobody took the time to define the acceptance tests or the definition of done. And without those, it's really difficult to mark something as feature complete. And especially with developers, we often kick the quality assurance can down the road, which is incredibly problematic in startup culture, such as Sensu, where there's not much dedicated QA bandwidth. So we have an issue with problem definition debt, and we also have an issue with test definition debt. But unfortunately, we cannot dare declare bankruptcy on it. But we really just need to be more mindful and take initiative on being verbose in the earlier stages of development, even if those tasks have some product and QA overlap. But again, say we do resolve some of that debt, executing the specified task is a breeze. So building software is easy, but shipping software is really, really hard. What build and packaging tools are right for our application? How do we validate all of this functionality? How much of this process should be automated? What even is quality assurance? How do we publish the final product to our users? And when is it done? I can guarantee that the answers to a lot of these questions will be unique to each person or organization in this room. But because there's no one-size-fits-all solution to releasing software, you can imagine that we experience some growing pains at Sensu. So releases should be simple, reliable, and reproducible. Simple and straightforward processes should be clearly defined and documented. Reliable cross-functional teams should all drive the same company initiative and deliver on time. And reproducible environments and workflows should help troubleshoot and debug potential regressions. However, this is what releases at Sensu looked like for a good amount of time. Hopefully the sound works, I'm not sure. I think it's coming from my laptop. There we go. Fire shooting at us. If you haven't seen the fire drill episode of The Office, I'm sorry I can't really help you with that metaphor any further. But releases at Sensu were complex, chaotic, and inconsistent. They were complex and mentally exhausting, with many manual processes often taking 10+ hours from start to finish. They were chaotic, as communication between cross-functional teams was lacking, and we weren't exactly inclusive or understanding of why. And they were inconsistent, with process churn and tasks that were next to impossible to reproduce. While there were many contributing factors to this brokenness, the most imperative solution to restructuring our release process was implementing virtually hundreds of automated end-to-end tests for release QA validation. I shared this story in a full-length talk at DevOpsDays LA like months ago, if you want to get filled in on the whole journey of how we got there. But the main things you need to know about our release QA for this talk is that we deploy an automated staging environment with Terraform. We run Ruby-based server spec tests, and we report results in TestRail, a test case management system. This is a slide from that talk where I outlined 5 major actions which defined our journey to create the Crucible. Afterwards, I was approached by a DevOps Day attendee who wanted to challenge number 4. He explained that in his organization, they did daily deploys, so they had no real need for a test case management system. All of their tests were just maintained by code. He also argued that any historical test results or bug trend analysis was really just a way to check a box for some managerial requirements. Granted, the software he was testing was a little less complex than Sensu, no tea, no shade, but this premise, this idea, is still totally valid and totally aspirational. At Sensu, however, this is a little bit more difficult because we still have some of that test debt in our web UI primarily. I'm a back-end engineer, but I would agree that testing the front end in an automated fashion is a lot more difficult. Until we resolve that by automating our front-end tasks, we still need some system in place to retain our manual test cases, such as TestRail, which is pictured up here on the slide. But my DevOps Day friend brought up a really good point, and I was determined to find a workflow that would allow us to eventually replace test case management and save money and enable continuous delivery. So Tyrion has a tender spot in his heart for cripples, bastards, and broken things, but I have a tender spot in my heart for testing, monitoring, and broken things. And those 3 ideas are tightly coupled in more ways than you might think. So tests fail, or at least they should, when an assertion in our code breaks. They aim to identify changes in a product's behavior before the users do. And monitoring, if done properly, detects and alerts us when our system breaks. And if a system is unhealthy, there are usually some warning signs that your monitoring tool should provide some insight into. So based on those assumptions, we're able to develop this super advanced matrix that monitoring and testing both relate to breakage in some way. We monitor systems and infrastructure for breakage, and we test our code and product for breakage. But how does monitoring and testing relate to each other? In our case, it's state. By monitoring the state of a pre-configured environment, we can run tests against the expected behaviors. And by transitive property, we're actually monitoring the product in addition to the systems which support it. Turns out this idea is not entirely new. I hit this harsh reality when doing research for the Crucible. There was a user of Sensu Classic, which is our legacy product, Michael Richardson, who discovered that by modifying the JSON output from server spec tests, that you can actually feed that data back into a lot of different monitoring solutions because it's JSON, YAML, whatever. And what better tool than Sensu, which is API-driven and stateful. In doing this, the Sensu dashboard visualizes the test suite as critical or OK events. I drew some heavy inspiration for this handler and rewrote it for compatibility for our newer product, Sensu Go. With some Go releaser and CI magic, you can download the configuration for this asset at the click of a button in it's an internal product that we call Bonsai Asset Index. This YAML config essentially tells Sensu where to retrieve the tarball required to execute the binary, making the workflow compatible for containerized and ephemeral environments. So let's see this handler in action. In order to save myself a sacrifice to the demo gods, because I have failed at this demo before, I've screen grabbed and gifified a living environment so I can focus more on explaining what's going on rather than troubleshooting issues. So let's start this video. All right, so here's a Sensu dashboard of our staging environment. With automated provisioning and configuration management, we're able to preload various Sensu resources, making sure it's playing. These resources are designed to interact harmoniously with each other and create a certain state from which our tests can draw assertions from. So let's dive into an example event that's created as a result of a defined Sensu resource. The execution timeout event is failing and prioritized over OK events, and it derives from the check called execution timeout, which is already on the screen and it disappeared. Hopefully you saw that the command sleeps for 5 seconds and exits cleanly, and the timeout is configured to be 2 seconds. So theoretically, every time a check is executed, Sensu should recognize that the process is alive for longer than the defined timeout, kill the process, and return that failed event. So the event has a critical status of 2 and the output of execution timed out. So those behaviors are all asserted in our Ruby end-to-end test suite to validate that the timeout feature in whole works properly. Now, demo part numero dos. This is the server spec namespace, which is all of our testing and infrastructure and configuration. We have one Sensu check for each suite that we want to run. Run agent spec executes a shell script to invoke the rake file for the server spec tests. It's scheduled to run on a cron cadence every day at noon, and the same goes for the backend test suite as well. So for every new daily build, it will trigger tests against the backend server, and I think we're on to the agent suite. So let's see. If I ever want to diverge from like the daily schedule for some one-off testing, I can go ahead and execute an ad hoc check execution, which you saw right there, and the agent suite ran just seconds ago. So all of the events should update soon. The handler explodes the high-level suite into individual test suites, which are also listed on the screen there as different events. But in the case of the backend test, you can see that that output is like super, super big, and that's going to be really difficult for us to debug. So we would want to dive into the individual test suites itself. So here, I believe this is check subdue, and this is a failed test. But we've tagged it with a known bug in our test infrastructure, so we can just go ahead and resolve this event and forget about it. So the same thing for this other issue, it's also a known bug, so we can go in and resolve it. So at resolution, it changes the output to resolved manually by the web UI. So now that all the backend tests are passing, we can go ahead and resolve the entire event suite for the backend tests. I think we're in that was just a successful test, so you could see what it looks like. The output is a little less verbose when you have a passing test, which is probably a good thing. But now that we have everything resolved, green is good, and this dashboard is an excellent indicator that our product is free of regressions and ready to ship. So that's all fun and fresh. We've effectively replaced test case management, quite an expensive tool, with our monitoring solution. Sensu gives us a great overview of the current testability of our product, which also happens to be Sensu in our case. But let's say we're deeply interested in historical data and trend analysis for test results. Sensu is a little bit limited here. It only stores the 21 most recent check executions, and due to our daily cron setup that you saw in the demo, that's only 21 days of test runs with little graphical visualization. So it's time to pull in some time series data. We can assemble InfluxDB compatible metrics from those test results. And that same handler that pumps test events back into the Sensu API can also inject new handlers into it for when it passes through the pipeline again. For this, let's take it one step further and use our supported integration with InfluxDB. So by using the InfluxDB handler, which I'll explain in a little bit more detail later, in combination with the Sensu server specs event handler, which I showed the configuration for earlier, we can run server spec tests against our product, extract relevant test data, populate metrics from those tests, and store them in a time series database of your choosing, which in our case is obviously Influx. Add Grafana like that into the mix, and you can customize how you visualize your test suites. So pictured, I have a subset of check spec tests, and a spec 18, which is that disabled feature that we saw in the demo, was a known bug that exited with a critical 2 status, so that's graphed there. By analyzing the last 3 test executions, you can draw conclusions about the history of the failures. The data trend indicates that this indeed is not a regression, and especially with Grafana, we can set up different thresholds for graphing and alerting, so they have a similar pipeline if you were using this tool. We've set a threshold of greater than 0 or 1 to indicate a warning in critical failures. But whether you prefer the stateful UI of Sensu or the custom UX that Grafana offers, rest assured you're probably prioritizing testing and quality assurance with either workflow. So now that we can run and visualize test suites with monitoring, what's next? Sensu empowers this theory with its event pipeline, and the resulting process has implications on your workflow, your organization, and for continuous delivery. What does this mean for your org? I'm sure everyone here has those unique teams and organizations. Some of you may already run tests such as these in your infrastructure, while others may have separate teams responsible for that, or maybe people aren't doing any testing, which isn't great, but whatever the case may be, by utilizing namespaces and role-based access controls, you can centralize your monitoring and testing operations, especially if those are already kind of coupled within your org. And by hosting these results in your already running Sensu instance and Influx store, you can provide more visibility to cross-functional teams. If this workflow isn't relevant to your current role, and it may not be, I challenge you to break the silo in your org and collaborate with the teams that this may benefit. What does this mean for your workflow? By configuring testing events with other Sensu resources, we can take advantage of its core routing capabilities. One use case would be injecting an alerting handler, such as Slack or PagerDuty, to the newly created events. This allows the test event to pass back through the pipeline. If we're issuing alerts, we probably want to filter according to the event status, which reflects the test result. Lastly, to combat some of that nasty alert fatigue, you can silence test results that are already tagged as known issues. This configuration would alert operators only of unexpected failures with context about the result within the test output. So as an operator, if you get an alert, you can respond to new bugs quicker with this tighter feedback loop. And if you don't, just continue on to delivery and testing. What does this mean for my org? I can't go too mad scientist on you. If our team at Sensu dog-fooded our staging environment with our test results, a simple bug in the deployment we're evaluating could essentially break something in our workflow. So a more practical approach for us would be to run a separate stable installation outside of our staging environment. But for those of you that aren't developing and testing Sensu Go, which I don't believe is anyone in this room, you should be safe to use the same cluster like I demoed. But ideally, we would want to implement some configuration management to auto-update Sensu in a long-standing staging environment so we could deploy and test on a nightly basis, which would simplify our QA and release process significantly, because we still have a lot of manual steps just surrounding like the validation and shipping. And we could simply just promote builds that pass the Crucible, allowing us to release at a much higher cadence. Don't get too excited because we're definitely not there yet, but again, it's super aspirational. What does this mean for continuous delivery? If 100% of your release validation is automated, it's even more powerful because you can go ahead and ditch that test case management system. And by visualizing test results in real time, the Sensu Web UI can serve as a dashboard for dev and test orgs, providing immediate insight into the current build's health and stability. The same can be said for the time series data if you opt for the InfluxDB and Grafana stack. Let the dashboard, whatever it may be, inform a go, no-go decision and ship it. Okay. So let's switch gears a little bit, because we got really deep into storing test results in a time series fashion and monitoring tests for releases. But we haven't really grazed what we at Sensu monitor internally once our code is out the door. Spoiler alert, we also use InfluxDB for this. So as a monitoring company, it's only natural that we'd want to seek more data to inform our product decisions. With that in mind, we created Tessin, which is a hosted Sensu call home service. It's an opt-out data collector for anonymized data about Sensu installations, with the end goal being to benefit our community. The Tessin client, included in every Sensu backend, is capable of sending data on startup and then every 30 minutes thereafter. And this is transmitted over HTTPS. But all of this information and the actual metrics collected is completely transparent with our users via documentation and logging, and of course it's opt-out, so you can definitely choose not to report your data if you don't want to. Previously, we'd get this information anecdotally, collecting it ad hoc from different community channels such as Slack, but now that we have an automated method for Sensu deployments to provide us this key info, we can arm ourselves with that data to inform existing and potential users. For example, historically, it's been really difficult to answer questions like, how many Sensu servers do I need for an infrastructure that's X big? And with Tessin, we're able to collect data for broad usage, giving us insight into how many servers you'll actually need to keep tabs on the total visibility of your infrastructure. Additionally, it allows us to focus more of our developer efforts on features that are more widely used, backed by user data. So on the Sensu side, collecting that data is as easy as integrating some custom and Prometheus counters around key metrics in our pipeline and sending them over HTTPS. This is to kind of limit the performance implications on our actual product, because you don't want to be thwarting some of your resources because of your data collection. The Sensu server, however, is a bit more complex, unless you're an AWS Lambda whiz, which I am not. It uses a hub and spoke model, and which is a simple API that sends structured data to a central dispatcher. The API ingests metrics and sends them to an SNS topic, where an SQS queue subscribes to the topic. The queue, configured for Influx, receives a copy of all the data that's been sent to the topic. Next, a Lambda consumer is scheduled to run once every minute to consume data from the queue. So this data doesn't need to be super highly performant, like that interval doesn't need to be super high, because this user data is something that we just kind of look at on an ad hoc basis. But lastly, the consumer invokes another Lambda function to batch process the pulled data and write metrics to the instance of InfluxDB. So Influx has an excellent ecosystem for this data. Chronograph, which is hosted on Influx Cloud, provides us with this really colorful dashboard to visualize the anonymized user data. We uniquely identify each Sensu cluster by generating a persistent UUID, and we group our graphical queries by that value. So each line you see up there is a unique Sensu cluster. In the past 15 minutes alone, we've received countless payloads about how many check resources that users have configured. In an attempt to limit the load on our internal and embedded key value storage at CD, We disperse the count function calls over several minutes and cache the values until the interval triggers. We can also draw conclusions about the brute size of installations, with folks running over 2,000 checks versus just a couple hundred. Checks are a fundamental component to operating Sensu, so this graph just confirms that. But another metric that is proven to be rather informative is the event processing rate. The value stored in Influx derives from a simple Prometheus counter, which iterates each time an event is successfully processed in our pipeline. This, along with some other built-in prom data, is available to the user through our metrics API endpoint. But with Influx queries, we can translate those values into something more humanly readable and humanly understandable. So the non-negative derivative function was a fun one to figure out. I stumbled over that quite a bit. But with that function, we're ultimately able to query the counter against the derivative to calculate the rate at which events were processed per minute. Values such as these set a really good precedent that we could reference against in our developer initiatives to improve product performance. As a result of this, our engineering team very recently made amazing strides in improving performance. By analyzing time series data along with Go routine traces, the team identified and fixed several performance bottlenecks. Under excellent conditions with custom hardware and using Postgres as an event store, we've exceeded 40,000 events per second. So while the raw data we receive is anonymized, we also encourage users to register their cluster if they so choose. We instruct them to install Sensu Go and configure 10 checks and 10 entities to their cluster. This 10-10 rule has proved itself to be a good measure for success in helping new users get started. And we also incentivize them, those that register their cluster, by sending them some swag in return for their help. The community actively improves our product by allowing us to observe which features they get the most value from. So I've taken you through 2 internal use cases with Sensu and InfluxDB and explained how the database in particular impacts our processes. But if you're a Sensu user considering trying it, it might be beneficial for me to take you through some of the more common external use cases we see. My fellow engineer, Eric, coined this as the SIG stack because it utilizes Sensu, Influx, and Grafana, SIG. But you saw the stack kind of take a different form earlier in this talk for the test data. However, there's even more types of metrics that Sensu can handle. The idea here is that it can normalize metrics, consuming them in many different formats and different sources. So Sensu offers multiple mechanisms to monitor performance metrics, whether that be for your application or for your infrastructure. StatsD is a metric aggregator used to collect values such as gauges, counters, timers, and sets. And there's an embedded StatsD daemon that listens for UDP traffic on port 8125 on every Sensu agent. Because StatsD client libraries are ubiquitous and available in just about every language, you can instrument their tooling in your app's native language and send those metrics off to Sensu. Sensu service checks, on the other hand, collect data on monitored nodes and follow the same protocol as Nagios service checks. Remember, Nagios on steroids. Similar to how we parsed output for test data, we have built-in mechanisms to parse the standard out of a command that produces metrics in already known forms, hence metric extraction. So we provide 2 embedded solutions to push or pull your data, but spoiler alert, again, the more complex your stack gets, you'll probably want both. So with metric extraction, Sensu currently supports 4 different metric types: InfluxDB line protocol, OpenTSDB line protocol, Graphite plaintext format, and Nagios performance data. The key you see below each type, for example, InfluxDB_line, is the identifier that you would use to define in a Sensu check config. This determines which format the check output should be parsed in and mapped to the value output metric format. I've included a really simple CPU metric example in each format for reference. But for the sake of consistency, an example of metric tagging is not shown because they're actually not supported in every single one of these protocols. But for all of those that the format supports it, so does Sensu. Okay, on to the Sensu check config. So here we're defining a check called check CPU InfluxDB in the default namespace. The check command is a simple shell script that prints out CPU usage in Influx line protocol. You can see that one below at the bottom of the screen. But it's set to run every 10 seconds, only on nodes subscribed to collect metrics. And then the last two fields here indicate that our check output metric extraction will occur. The event that's produced contains not only the execution context of the check, such as status, output, duration, etc., but it also contains entity information about the monitored node, and lastly, and most importantly, the extracted metric. So now that we have a collection of metric points within a Sensu event, what do we do with it? So Sensu obviously has tight integrations with many time series databases, so you could just pick one. InfluxDB has a super simple Golang client, and Go is my language of choice, so that's what I chose when I built the open source handler. But this config on here invokes the Go binary Sensu InfluxDB handler, which accepts options such as the address, username, password, DB name, and precision as command line flags or environment variables. Any additional metric tag enrichment can happen as a part of the event pipeline before the handlers, such as this one, eventually accept data through standard in. The metrics contained in the event are then sent off to the configured time series database. While this pipe handler that I wrote works great for our purposes, TCP handlers and extensions have historically proven to be more scalable for processing metrics. Luckily for Sensu, those avenues are both supported as well. I could optimize performance of this handler by writing a Golang TCP handler, which uses the same InfluxDB client. So to overview quickly, a Sensu backend will send service checks to monitor nodes with installed Sensu agents. A Sensu agent will execute a check, extract metrics in any of the 4 supported formats, and then the Sensu backend will receive that event data and pass it through the monitoring event pipeline. So this specific use case includes filtering events only if they contain metrics. There's no use in doing anything with those events if they don't. Mutating them to enrich metric tags and add additional context about the data and source, and handling those events by sending them off to a time series database. This diagram folds back in those statsd metrics that we touched on a little earlier, and additionally another integration with the Prometheus metrics endpoint, which we use both internally and externally. But essentially, any telemetry event that the agent receives will be processed by the backend. This is important because in order to have complete visibility of your app, service, systems, and infrastructure, you'll likely need to retrieve data from multiple sources. So although this workflow is just for telemetry data, it's great that there is a single entry point for all of it, because as you start to add different event types, such as availability and alerts, you'll be thankful that the pipeline is dynamic enough to support reusability all under the same hood. Finally, time series analytics and visualization provide a critical, convenient overview to your infrastructure. In this dashboard, again, I'm not a Grafana whiz either. I'm probably the worst person with UX. I'm a back-end dev. But in this dashboard, there's a single data source as far as Grafana is concerned, which is InfluxDB, because we let Sensu do all of the heavy lifting. The Sensu checks shown here are displaying metrics from different Graphite and Influx protocols, while the statsd daemon is tracking all API calls and request rates for our application. I'm actually dog fooding the Sensu API here, or as we like to call it internally, drinking our own champagne, because it sounds a lot nicer than eating your own dog food. But you can actually measure every API call in a Golang application in less than like 30 lines of code. So if that sounds really attractive to you, come find me and I can give you some resources to do that. But that's what I've done here to create this dashboard. So boom, it's magic. Your test data, availability data, user data, Prometheus metrics, statsd metrics, Influx, Graphite, OpenTSDB, and Nagios metrics. All of the metrics are persisted to InfluxDB. So raise the roof, because your monitoring's under one roof. So that's all I've got for you guys. Did someone raise the roof in the back? Nice. Thank you for listening to me nerd out on testing, monitoring, and metrics. I don't know if we have time for questions or not, but we have a Sensu booth out there that you can come track me down and whatever. So thanks, guys.
So real quick, we know you're going to be leaving this afternoon.
I'll jet out of here too quick.
For those of you who don't know, I'm Tom Crow. I'm our community manager here at InfluxDB. And one of the programs I run is called our InfluxAces program, where we find people in our community who are real rock stars and standouts. And a couple of weeks ago, Nikki was nominated. And our ACEs are self-regulating, so Dylan here is one of our ACEs, and they voted and have accepted Nikki as an ACE. So we want to officially present you and welcome you as an ACE.
Thanks. What do I do? Oh, thank you.
We order you cooler swag.
Oh, sweet. That's really what we do it for, the
Right?
swag, right?
That's pretty much what they said.
Yeah.
So,
awesome, thanks.
You're welcome. So we'll just,
What a nice surprise.
if you have a second, I'd like to get a picture of you two
Yeah,
together.
for sure.
Awesome.